Okay, with chapter 8, biggest thing that they look at here in the beginning is, especially with section 1, is they're going to look at domain and range. Okay, and here's really all you got to worry about with domain and range when you go through these. When we're talking, this is coming from ordered pairs. They can also have it where it's in different ways they set this thing up, but really it's ordered pairs. When I talk about domain is just your X values. They possibly could also talk about input, output if they're talking about functions, which we'll talk about in a little bit. So you can also say in this case that that would be your input. When I talk about range, that's equal to your Y values. Which is going to be your output. Okay. And all they're going to do with objective 1 is they're going to tell you, okay, here's some ordered pairs. Tell me what the domain and range is. And the way they'll set this off is they'll say, all right, here's just a big group of, this is what they would call a relation, where it's just a big group of numbers, big group of ordered pairs. It could be 0, 4, it could be 2, negative 6, it could be 8, 5, and then 10, negative 3. Okay. And again, for your domain, it's just go back and tell me what the numbers are in the X values. That's going to be 0, 2, 8, and then 10. And I think they make you put a little, they may make you put a little bracket symbol around it just to show it. And again, that's not a big deal. That's just more just kind of getting used to the notation that they have you go through. And range, well, same thing. That's just going to be your Y values. So 4, negative 6, 5, and negative 3. Okay. Now, if a number happens to repeat, let's say that this first number, let's say this had been 8 and 4 twice. If you get a number that's listed twice, you know, if it was 8, 2, 8, 10, you don't have to write the number twice. Because if you've already said, well, 8's part of the domain, and 8 pops up again, you don't have to write it down twice. So if it ever repeats, you don't have to go back and write it twice. As long as it's in there once, you know, that's all that you have to worry about. And other than that, that's about the only thing they can do. And again, if they give it to you in numbers or variables, some of these they'll throw some variables at you. You still just take whatever numbers they have. You know, if this had been a B at the front, you still just go back and put a B here. But it's, all that they're trying to get you to see is when you're going through these, is that if they talk about the domain, that's just your X values. If they talk about the range, that's just your Y values. The only other thing they do, and this was objective 2, is, and this may be a little tougher to do it because we don't have, used to, they had an actual grid lines, had actual graph paper at one point in time. That might work. Oh no, don't want that. No, don't want that. Okay, this will work. Okay, that if they give you a grid, let me get down here with actually. There we go. Turn the page down just a bit. That what they would do for one like this is they'll actually give you ordered pairs for something like this. So they'll come back in and mark off your X and your Y axis. And then what they'll do is they'll give you just individual points along the way. So they'll maybe mark a point here, maybe mark a point here, maybe another one here, here, and maybe somewhere up here. And they'll do the same thing as they did on the first one, where this time you have to go back and list the domain and range. And all you're going to do in this case is you're just going to take each number as an ordered pair. You have to go back and tell me what the ordered pairs are. So for the first point that you have here, that's at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the first point would be at negative 5, 5. So when you start to list your domain, well, it's negative 5. For your range, same thing, we'll put a 5. Okay, and then you go to the next point was here. We'll do this one. This way you color code the points. So that was in black. If we put this one in blue, that's at 1, 2, 3, 4. That would be at negative 4, 0. So your domain there would be negative 4 for the X, 0 for the Y. This is negative 4, 1, 2, 3, 4. This one's also at negative 4, negative 4. Now again, you've already got the negative 4 here for the first one, so you don't have to put it again because you've already gotten the negative 4 twice. You don't have to worry about it there. If we go with that one in purple, that's at 1, negative 1. And the last point, we'll leave it red. That's at 1, 2, 3, 4, 5. 1. That's at 5, 5. Okay, so we need 5 for the domain. And we already have 5 for the range here, so for that one, we don't have to do anything else. Okay, so first two objectives, that's all they're doing is just having you work on domain and range. And it just comes down to domain is just your X values, the range is just your Y values, and you just list those off. And again, if you do get any repeats, you don't have to repeat it. It probably would still let you and count it correct if you do put repeats, but technically you don't have to. If it shows up once, that's all you have to have. Okay. And first two objectives, really not anything tricky on those. They just go back to domain being X and your range is Y, and they're just trying to hammer that point across when you go through those. Okay, so 8.2 just talks about functions. And we're going to talk about 2 or 3 different things on this one. And here's basically what it comes down to with functions. It's more of what functions do not have. Functions do not have repeated values. In the domain. Okay, so and the big thing, there's nothing about the range when you talk about functions. That what makes a function is all about the domain. It's basically like a vending machine, if you want to think about it this way. That if you go up to the vending machine and you want to get a Mountain Dew, and you punch the Mountain Dew button and you get a Diet Dr. Pepper. you're not getting what you wanted, right? And then you go back and put money again. The next time you get a Mountain Dew. Well, if it gives you something different when you do the same thing, that's not what a function is. A function says, all right, if you punch, the Snickers button, you should get a Snickers, right? If you punch the Snickers button and you get, I don't know, pork rinds. That's not what a function is. A function is basically if you punch this button, you know what you're going to get out of it. And a function basically says, all right, if it's not a function, you might get this, or you might get this, one of those kind of things. It's basically like an experiment when you go through it. And all that you're going to do, again, is you key on the domain, and if you ever see a repeated x value, then that's going to let you know that this thing is not going to be a function. Now, the first thing they do with Objective 1 when they go through this one is they give you more drawings, and it's less of ordered pairs. They throw some ordered pairs at us, but they call this a mapping. And I guess why they call it a mapping, I'm not always exactly sure, but it's basically something like this. And they'll give you all kinds of different drawings on this one. So it may be that they give you like, bear, fish, dog, and cat as part of your domain. And for your range, it may be that it's 2, 3, 4, 5. Okay, and again, they'll give you 2 or 3 different options on this one, so we'll look at 2 or 3 different ones. And maybe something like this. And then the question is going to be, does the diagram or does the relation, depending on how they word it here, represent a function? Okay, and all that you're doing is that if you pick something in the domain, does it pair up with exactly one answer? So bear has 3, fish has 2, dog goes to 4, and cat goes to 5. So if it asks you for one like this, yeah, it's a function. So we'll do 2 or 3 of these because they throw some different things at you. So maybe, again, like this, where it's, again, it may be that just don't match up at all, but the main thing that you're really doing on this one is you're really just worried about the arrows in here. I mean, that's really what it comes down to. We'll do this one where you actually get some numbers here. And maybe something like this, where you get -6, 0, 5, and 10. Okay, and really what it comes down to is as long as you've got one arrow drawn from every number in your domain over the range, and again, you're really not even worried about what's happening over here. But for this one, you've got 3 goes with 0 and you've got 3 goes with 10. So this one would be a no. And again, the reason why is that 3 in the domain goes with 0 and with 3 goes with 10. Three different answers drawn to the range. Sorry. Okay. But again, all you're looking for is if I get a number that's over here and it's got two arrows drawn from it, that's what's going to make it a no. back up here, again, you just one arrow, one arrow, one arrow, you're good. This one needs to go down the line. This one's good, this one's good, but as soon as you got 2 arrows coming from the 3, that's what makes that one up. Okay. And no matter how they draw those, they can label them all kinds of different ways. That's really what it's going to come down to. You know, let's do this. Let's get 2, so you got just a big order pair here. Let's go with. Okay, so maybe it's 2, -3, 4, -3, 5, -3, 6, -3. And again, if you want to look at this one a different way, they may give it to you also. Where it's like this. Okay, so these two are basically the same thing, just again, one with the listed ordered pairs, the other one where they use what they call a mapping here. And again, it doesn't matter that they're all pointing to the same number, but as long as there's one arrow here, it's good. As long as there's only one number, and you've got 2, 4, 5, 6, there's no repeats here. So even if they're all pointing to the same number, that's fine. As long as you've got one arrow drawn from each value of the domain, then it's going to be a function. Okay. And again, it doesn't worry about don't worry about the domain or the range part of it, because some people, you know, they like, well, it's pointing to the same number. That's fine. It doesn't matter. You can just take the range out. It doesn't matter at all. It doesn't matter how many numbers you have over here. Just as long as you got one arrow from the domain, that's all you worry about when you're looking at this part. Okay. Second objective that they'll look at in 8.2 is the vertical line test. Okay, and it's a spin-off, it's a different way of checking for functions. Instead of giving you lists and ordered pairs, this is one where they give you a graph. Okay, and you can be an optimist or a pessimist on this thing, and I'm going to give you both if you want it here. We'll give you the pessimist side of it first here. If you draw any vertical line through a graph, and it intersects 2 or more times, it is not a function. Draw any vertical line. If it intersects 2 or more times, then it's not a function. Okay, if you want the optimist side, if you want to be, sunshine, roses, and all of happiness and rainbows, if you draw a vertical line and it only hits it one time, it is a function. So whichever way you want to think about it, it doesn't really matter. Some people are more optimists, some people are more pessimists. It's just as long as you kind of know what's going on with it. And when they do these, they're not going to do anything really weird on this. It's basically going to be, and we'll do a bunch of different graphs here. But they'll come back and give you a graph like this. And they'll ask you, okay, is this thing a function or is it not? And you just got a choice. It's either function or not a function. And again, then all you're going to do is basically go back and just draw as many vertical lines as you want to through this thing. That hits it once, we're good. Hits it once, we're good. It doesn't matter how many times you draw any vertical line you want to on this thing. It's only going to hit it one time. So that's not what I wanted. So they ask you, is this thing a function or not? Yes, it is. If they gave you a circle, well, as soon as you draw one right down the middle of the circle, you're going to hit it 2 times. You're going to hit it here and here. So ask you, is that a function? Nope, it's not. About the only thing I could think of that they would do, and again, they'll just draw you all kinds of different shapes on these. The only thing that not that you'll have to watch out for it, but they'll give you just random points scattered around. Something like this. And it's still basically one of those things where, again, you just go back and draw a vertical line. If you draw it and it hits 2 points here, then it's not going to be a function. Because again, you're intersecting it here and you intersect it there. So when you hit those 2 points, then we're okay. If you take one of these out, if you took this one out, then we're okay, because you've got 4 different dots and they don't stack up on top of each other, but you put that one here. Maybe do something like this, where you've got 2 lines stacked up on top of each other. Same thing though, right? You can draw a line here, hit it 2 times. So that would be enough. Okay, the only way I can think of on this one that they might get a little bit tricky with you is they may do the 2 lines thing and have one like this, or maybe they're using like solid circles and open circles and that kind of thing. They possibly could do one like this where you've got 2 different lines, but these 2 lines have open circles. And again, if you have open circles, that means you're not really, you're close to it, but you're not there. So no matter how many times you would draw a vertical line through one like this, you're going to hit it once here. You're going to hit it once here. You're going to hit it once here. And because these 2 graphs are open, 2 circles are open, you don't actually get to use that point. It's just saying you get really close to this thing, but you're not. So as soon as you go to here, well then for that problem, no matter how many times you draw it, you're only going to hit it 1 time. So that one would be a function. Okay, now here's where that tie, if you ever want to kind of figure out how that ties in and what that does for that part of it. Y'all know what the equation is for a vertical line? Did we talk about that? I don't know, didn't we? And we talked about slope and tilt everything. Did we talk about just if it was horizontal and vertical lines? I can't remember. Okay. Did we talk about slope or am I thinking about something else? Okay. Here's basically what it comes down to if you're doing this. I'm thinking about my classics part. When you draw vertical lines or horizontal lines, the thing about slope and the equations of lines is that basically if you only go one direction, either horizontal or vertical, you only use one letter. And the letter that you use is basically, you would kind of go back and tell all the points that you had. So, if you were graphing a line that was like this, and you talked about, let's say you had a vertical line that was here. If you went back and graphed all the points on this line, let's say this was at 1, 2, and this was 3. If you talked about every point on this line, whether you go up or down, doesn't matter which way you go. If you went back and plotted all the points here, the one thing they would all have in common would be the x value. So you started at 3, 0. This would be 3, 1. This would be 3, 2. So when you draw a vertical line, that's all it's doing is just checking your x values, which is your domain. And if you ever hit 2 points on that line, well, now you got 2 repeated values. And so that's where the two things tie together when it comes down to that one. If you had to do an equation on this one, this would just be x equals 3. Because it doesn't matter what you do for y, the x value is always 3. So it's a constant number that goes with that. So that's why that works on the graphs, is that when you do the vertical line test, it's looking for the same x values. And that's really what it comes down to when you go through that. What's your objective vote down here? It's 3 or 4. Is it 4? 3? Okay. What the pen's doing here? Okay, not sure what's going on. Let's do. Okay, so with objective 3, now they actually start talking about function notation. And here's what it comes down to when we talk about function notation. Best way to think about it is if we had an equation, and we'll, if we were getting ready to graph some equations, let's say you had like y equals 2x plus 3. If you start with a normal equation that's written as y equals something, whether it's any kind of function, we'll stick with something that we could graph here. Here's basically what it comes down to for function notation. They're just going to replace y with f parentheses x. Now, the biggest thing on this one is it's not f times x. So when you read this one, it's f of x. It's not f times x. Because sometimes with the parentheses, we're used to knowing that that's multiplication. Well, if they talk about anything with functions, when you're going through something like this, they should say something about it being a function, so when they write it this way, you know it's not multiplication. So whenever they're going through parts on this one. Now, you still work it the exact same way. You're still going to go through and do the numbers, and you're still going to, everything kind of works the same thing. The biggest difference is if you have something like this with an equation that was, y equals 2x plus 3. Usually they would do something like this. They would tell you to evaluate for y when x equals 4. Okay. And people, when they started working with functions, they were like, okay, we can do this without having to use all these words. So when you've got an equation that looks something like this for a function, here's what they're going to do. It's going to be f parentheses x equals 2x plus 3. And instead of writing out all the words, they're going to say, all right, just find f of 4. Which is the exact same thing, because all they're doing now is that they're basically taking out this x, and you're going to replace it with 4. Okay, and if you did that, here's basically all you can do. And for me, the best thing I could always kind of do when I was working through these is when they tell you to do something like this, right underneath where they give you whatever part they've got given here, you just go back and write down the part that they tell you. So we're going to do f of 4. And all you've got to see is that everywhere you've got an x now, you're going to replace it with a 4. So same thing over here, you're going to take out this x and replace it with a 4. Everything else is going to be the exact same thing. And the biggest thing is that whenever you put a number in, if it's in parentheses here, when I do this f part for the function, when you plug the number in for x or whatever variable they give to you, just put it in parentheses. And then you just work it out. 2 times 4 is 8. And 8 plus 3 is 11. Okay, now here's the big thing with this one, because this is not, well, sometimes people want to go back and try to divide by 4, because they say, all right, the answer is f of 4, I'm going to go back and divide by 4. For these, you don't do that, because all that this f of 4 is, it's just a notation type thing. So that's your answer. You don't do anything else with it. You just work out the right-hand side. That for functions, you basically don't do anything to the left-hand side. So all the work that you do should be on the right-hand side, where just like for this one, if it said find f of x, or plug in x equals 4, you know, you would go back up here, plug in the 4 for x, you know, and work it out and do the same thing. You know, but here it's the same process. They just don't tell you this, they just give you this one little thing to plug in here. Okay. And the way they're set up in the homework is that they're going to give you a box full of numbers. They'll do the same type setup on one like this, is they'll give you a function. They'll say, all right, well, maybe this one's going to be g of t. So sometimes they'll change up the numbers just to give you some different parts of it. And maybe this thing is going to be, you know, t squared. No, I think it probably was earlier. So like negative 4t minus 7 or something like this. And then they'll come back and just give you a box that's here. And they'll say, all right, here's your t value, and here's g of t over here. And they'll give you like negative 3, 0, 2, and 4, something like that. And they're going to leave this blank in here for the g of t. And that's all that you have to do is, again, you're going to take out this t value that you have here, and you're just going to take that number and plug it back in for this value over here. So it's negative 4 times negative 3, which would be 12, minus 7, which would be 5. So that would be your 5 value that you would put there. Okay, next time is, again, you'll take the 0 that you have here, plug it back in. So now it's negative 4 times 0 minus 7. Anything times 0 is 0. 0 minus 7 is negative 7. So then you put the negative 7 in here. And then just keep going down the line on these. You know, next time you'll plug in 2. So it's negative 4 times 2. That's negative 8 minus 7 is negative 15. Okay, the last one we'll plug in 4, so it's negative 4 times 4 minus 7, negative 16 minus 7, that's a negative 23. Okay, and it's just practice of just knowing, okay, if I have a number, we'll just go back and plug it back in. It's the same setup as an equation, it's just, again, most of the time you would have a big y over here equals this number. Well, now instead of just being y equals, now they put a function where it's g of t or f of x or h of v or whatever the variables are. It's still the same thing. They give you this number that's here for this variable. You take that number, you plug it back in, and you just work it out through that equation. And there's really nothing that you do on this side. That's just the notation of saying, all right, here's the name of this function. That's really not the important part. This is the part you're going to work with over here. Okay, Objective 4 is pretty much the same type thing, but they kind of go back to the first part that they were doing with Objective 4, is for one like this, they give you functions, and all they do on these is they take up the powers of the functions a little bit. It may be that f of x is x squared minus 3x plus 2, and then it may tell you that g of x is x to the third minus 10. And they may tell you, all right, for part A, we're going to find f of negative 2. And then for G, maybe you're going to find G of 3. Okay, still the same setup, just kind of going back through the numbers. Actually, let me change this first one just about a little bit. Let me make that a negative x squared. Because there's sometimes people will get this one a little bit off if it's got a negative in here. And again, if you can get in the habit of doing, especially with functions, if you get in the habit of doing this, it will save you the headache from getting an answer and not realizing why you got the answer that you had. For a problem like this, and again, we're going to go into this part, so we're plugging this thing back in here, that everywhere we have an x, we're going to take out the x and replace it with a negative 2. So you got negative 2. Everything else around the x has to go on the outside. So this negative goes on the outside. This squared goes on the outside. You've got a negative 3 times negative 2 and negative plus 2. And if you can get in the habit of taking out whatever the x value is and putting it in parentheses, everything else has to be on the outside of parentheses. So if there's everything else going around the x, it has to be outside the parentheses. The only thing that can be inside that number is that number. Or sorry, the only thing that can be inside the parentheses is the number that they give to you here. So if you have a negative x squared, the negative goes out front, and then the squared goes up here with just the negative 2 that's on the inside. And from there you can work it out by hand. If you got a good enough calculator, you just punch it in and let the calculator do the work. And if you did this, you got negative, because it's going to go through the order of operations for you, it's negative 2 squared, which is 4, and the negative is still out front. Negative 3 times negative 2 is a positive 6 plus 2. Because again, what it's going to do is it's going to do this part first. It's going to do the 2, it's going to the exponents first. It's going to do the negative 2 squared to get 4. This negative that was in front is still just hanging out there. And then it's going to go back and work it all out from here. Negative 4 plus 6 would be 2, and then 2 plus 2 would be 4. Okay, and that one little, sometimes that one little negative throws people off, as they're going through a problem like that. But again, when you do order of operations, you're going to do the exponents first, so you're going to do negative 2 squared to make it 4, and then the negative goes in front of that number every single time, no matter what you go through there. Okay, and then for the g part, we got g of 3 is equal, and that's x to the third minus 10. So that's going to be x, which again is 3, to the third minus 10. Three to the third is 27. 27 minus 10 is 17. Okay. Sometimes they're long, sometimes they're short, but again, it's honestly, if you've got a good enough calculator, a lot of times it'll do the work for you as long as you can put the number, in the right place in the right order when you go through that. Okay, so, and again, the only difference that they do from objective 3 to 4 is that I think objective 3, everything is x to the first power, which is linear. And objective 4, well, now they give you x squareds and x to the thirds and, different powers, like cubic and quadratic powers when they talk about it. Okay. All right, for these, they get to word problems. Now, and when they get word problems, you're going to have something like this. construction crew is lengthening a road that's originally measured 51 miles. The crew's adding 1 mile to the road each day. The length in miles after D days is construction. Following the equation. They give you a lot of words and stuff and fluff on this thing. But here it comes down to this. You've got this one equation that's here, and they give you this number. Just take that number and plug it back in. So they're going to give you all this word problem stuff here. So objective 5. Oops, sorry. What did I say? It's word problem. And they're going to say blah, 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 blah. And then here's an equation or a function. L of D equals 51 plus D. And they tell you that D equals 18. Just plug it in. It's 51 plus 18. That's 69. And you're like, really? That's all that? Yes, that's all they're going to do. They give you this word problem. They give you a simple little function that's here. And then they tell you, all right, plug in 18 for D. And you're like, look, you just got to be more than that. No, it's not. It's going to be that simple. It's going to be add, subtract, or multiply, or divide. And that's it. That's all you're going to do. So they give you this one word problem that looks like it's a lot of stuff, and it's really not that bad when it comes down to it. Objective 6 is the same top thing. It's another word problem. And they'll do the exact same thing. They give you blah, 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 blah. And then they give you an equation that's now maybe just a little bit tougher. It may be that you get like h of t is equal to 4t minus 50. And work this thing out when t they're not going to say this, but basically they're going to say this. Find the answer when t equals 50 hours. Well, again, you're going to take this t equals 50, plug it back in, and then you're just going to work it out. And then you got 200 minus 50 makes it 150. Okay, so objective 7, same word problem, but this one they kind of give you some word problem answers and questions with these. So they'll talk about, you've got a railroad track, train, crew, and they're laying this, and they're given this function to know how much they've laid in a day. So they'll tell you, all right, here's what we got. How much track is left after 18 days? So for this one, basically you'll take the 18 and plug it back in. Part A, we'll take the 18 and plug it back in, so that's 140 minus 5 times 18. It's 140 minus 9. So if they work 8 days, length 5 miles per day, or whatever, then there should be 50 miles that's left to go. Okay, and maybe I made a bad choice for the B part here. Well, we'll leave it there. Because on the B, well, actually, let me change it. Because we've already got the answer here, so I think we're okay. Let me change that one to, let's just change it to 108. Okay, so one like this where they tell you what the total amount is and they want to know how many days it's left, so you're not getting the D part of it. That basically for the B part is that if this is what total miles they've done, that's basically your answer that's here. So you got 180 is going to equal 140 minus 50D, or minus 5D. So if they don't tell you how many, if D stands for days, if they give you the other number, then that's basically your answer. So from this part, then you go back and then just work this thing out. Oh, wait, sorry, hang on. Take it the other way. because the D's are over here. So let's go back for this one and let's subtract 140 from both sides. Okay, so if you do 108 minus 140, that's a negative 32 equals a negative 5b. Then just go back and divide by the negative 5. So that's 32 over 5 equals d. And if you get a decimal, and they should tell you whether they want fractions or decimals on one like this. Probably one like this, they might let you leave this 32 over 5. If not, then they may just let you round this thing. Go ahead and give you a decimal number. So if we did this would be what, like 6.4 days. Maybe they got rained out for half a day. Okay, so still word problems, and again, the only thing that might be the least little bit different in one like this is they'll give you two different options. One where they actually give you what the D value is. The other one where they tell you not what the D value is, but what the answer is that you're looking for. And then it's just a matter of plugging it in on one side or the other. Okay, so they're still just word problems, just working through those. And again, they shouldn't be too awfully complicated when it comes down to it. Okay, the next thing they're going to do is they're going to jump back to a domain and range type problem. Objective 8. That they will give you a curve. Let's see, let me go back over here and pull in another graph real quick. So one like this, I could freehand it, but it's better if I can get the graph on here. Okay, so again, they'll give you an XY axis. And then they're going to go back in and then draw out a graph that maybe looks something kind of like this. Okay, and they're going to go for this part, and they're going to tell you to state the domain and range. And the one thing that's going to be different about this one is when they do this part of it, they're going to throw something new at you. They're going to tell you to use interval notation. Okay, and all the interval notation is basically because you've got an endless amount of ordered pairs through here. Let me see if I can make this graph just a little bit better. So it should bottom out right here. I can't just draw in, so let me do that so it bottoms out just a little bit better. That'll work. But basically, when you're talking about interval notation, you basically just tell me if you're talking about domain. When you're talking about interval notation, basically you tell me what the left-hand value is in your domain, how far left you go on the graph, and then you tell me how far right you go on the graph. When you talk about the range, you're going to tell me what's your low number, and you're going to go to the high number. So for domain range, you tell me what's the farthest number on the left, and tell me what's the farthest number on the right. range, again, because it's the y values, that's moving up and down on the graph, so you tell me what the lowest number is, and then you tell me what the highest number is. And when you use interval notation, basically is this. This is similar to when you would graph numbers, how we would use brackets and parentheses, open circles and closed circles, that kind of thing. That how you kind of counter that part in is that if you have a value that has an open circle, for one like that, you're going to use a parentheses. And if you have a solid circle, then that's when you're going to use a square bracket. Okay, and they really, and this would be one of those things where you'll keep getting the review objectives you have to go back and pick up on. This is one where they'll probably make you backtrack and do some interval notation things to get comfortable with it, because they kind of throw this one at you, and they don't really talk about this one. It's just, okay, here it is, and here's interval notation, and whoa, where did that come from? So this is one where they kind of throw you off. So basically, here's what you do. When you're talking about this one, where's the left part of the graph? What's the leftmost point that's on this graph? Right here, right? So for this one, you go back, tell me what that value would be on the x-axis. So that's 1, 2, 3, 4, 5, 6. So this point's at -6, 1, 2, 3, 4. Okay, now, and if you're talking about left to right, you don't even really need the second number. You just need the first number, because that's what interval notation is. Or sorry, when you talk about domain and range, domain is just your x values. So you tell me what's the leftmost x on the dot, you tell me that number. And this was a solid circle. So for domain, you're going to tell me, all right, my leftmost point's at -6. If I go all the way to the right side of the graph, that's this point. And that's at 1, 2, 3, 4, 5, +6. And it's an open circle, so you're going to use a parenthesis. Okay, for the range, now you're talking about up and down. Tell me what's the lowest point on the graph. This point right here, right? And for range, again, this is all about your y values. So you go to this point, which is at -2, -2. But again, you're not really worried about the x value. If they talk about finding domain and range, you look at y values. Your low number here is at -2. And basically everything on this line would be a solid circle. So this one, you're going to start at your low point of -2. And then you tell me, all right, what's the highest point on the graph? Well, that's also here at this point, which was at, what did we say that was? That was at 6, 7, 8. That was the point at 6, 8. But if we're only doing the range, again, we're just worried about the y value. So that's also at 8 here. It was an open circle, so we'll do something like that. Okay, so again, they don't really, when they jump to the objectives, they don't really do a whole lot with interval notation. They just throw it at you, and then all of a sudden it's coming out from left field. So this is one of those things that it's probably going to be some review objectives that they're going to, prerequisites, that they're going to make you kind of work into this one to go back and go through this one. Because, you know, we talked about domain and range, but then all of a sudden they throw interval notation at you, and you're like, okay, where did this come from? And all you have to just think about is that, again, when they talk about interval notation on the graph, if it's domain, you tell me, what's the farthest point on the left, and give me that x value. Then you give me the farthest point on the right, and give me that x value. Because domain is always your x values. When I talk about the range, tell me the lowest point on the graph. Tell me the highest point, and those two things you would only talk about the y values. When we're talking about domain on this one, again, we're looking at the blue numbers, so we're only looking at the x values. When we talk about range, you're only talking about the y values. Okay, Objective 9, they kind of jumped gears from everything else that was going on with Objective 9. Again, every notation, they just kind of threw that one out there in the middle of nowhere. But you're going to have something like this where you got f of x is equal to x minus 12, or 4x plus 12. Okay. And the only thing they're going to tell you on this one is if it's not possible, there should be an option where you click on undefined. So they'll give you a button that says, I think it's undefined is the word they're looking for here. Now, and they'll kind of bring that part of it in for that part. Here's the undefined part on this one. Where you get something that's undefined, that's when your denominator is going to equal 0. As long as the denominator is not 0, you get an actual answer. But if you plug this thing in and you get 0 in the denominator, that makes it undefined. Okay, so a problem like this, they tell you to find g of 7. So everywhere up here we've got x, we're going to take out the x and put in 7. Okay, 7 minus 12 is negative 5. 4 times 7 is 28. Plus 12 is 40. And if you have negative 7 over 5, you can simplify that fraction down to be negative 1 over 8. Because you can divide both of these by 5. Okay, and again, as long as your denominator is not 0, you get an answer. If the denominator is 0, it's undefined, which means that the answer doesn't exist, and then that will kick that answer out. Okay, in Objective 10, same setup, same type thing. They just changed it that now you've got a little bit more complicated expressions that you're working with. Still the same thing as you're working through these, that whenever they give you this number, if it's f of negative 3, same thing. Everywhere you've got an x here, you're going to take out the x and you're going to put a negative 3 in its place. So it's negative 3 squared minus 5 times negative 3 minus 24 over x squared minus 1. Okay. Again, depending on the calculators and how much you go with these, if we're working these out by hand, you got negative 3 squared, which would be 9. On the bottom, go ahead and do these. And again, you can, if you're doing this by hand, you can do the top part as one fraction, as one like answer, then you'll come back to the bottom. So this one, you'll do the exponents first to make that 9. You have negative 5 times negative 3, that's a positive 15, minus 24. So that is 24 minus 24, which is 0 on top. Now, from this point, it all depends on what the bottom number is. If the bottom number is 0, it's undefined. But in this case, the bottom number is going to be 8. And as long as we get 8 on the bottom, if you take 0 and divide it by 8, that should just be 0 for the answer. And again, 0 on top is fine. 0 on the bottom, that makes it undefined. And again, if you get stuck on that one and you forget about the 0, just take out your calculator, punch it in real quick. If it tells you it's undefined or an error message, then you know it's undefined. If the answer is 0, then you're just good to go with the 0. This is 11, yeah. So they're going to tell you the list of excluded values. Now, and this is where they're going to kind of piggyback off the last two parts on this one. If they talk about excluded values, all that's going to be is that's going to be values that make the denominator equal to 0. So for everything in this one, they're going to basically say, all right, here's some expression that we have, some rational expression. F of x is 2x minus 7 over, and they'll give you all kinds of different things. I think that a lot of these, they'll stick to some problems that maybe something like this, where you got f of x is equal to 2x minus 7 over x squared minus 4. Okay. And again, whenever they talk about that one, there's really not much with the numerator. All you're going to do is you're just going to set x squared minus 4 equal to 0. And for most of these, you're going to basically just factor and solve. If it's x squared. If it's not x squared, then it's basically, you can just jump straight into it and solve it. But if it's x squared, you're going to have to do some factoring and solving on those. Okay, so for this one, you have two terms, and if you still got the factoring worksheet with two terms, you had two options. It's either greatest common factor, which is not 1. In this case, there's two perfect square numbers here, because x squared would basically be x times x. 4 is 2 times 2. So to factor this one off would be x plus 2 and x minus 2. And setting both of those equal to 0, real quick, you figure out that your answers are going to be positive 2 and negative 2. Okay. And on this one, it's really a factoring review question. They'll give you all kinds of different options of expressions in the denominator that you've got to go through and factor. It may be one where you've got a perfect square like this. If we give you a different example, maybe this t squared minus 10t, minus 24. With the same directions, go back and list what the excluded values are. Okay. And again, all you're doing is you're just going to take whatever the denominator is, factor it off, and then set that equal to 0 to get what you're looking for. So for this one, it's the factors of negative 24. Where the sum is negative 10. Okay, and sometimes like these, you just have to be careful with the numbers, because some people go, oh, well 6 times 4 is 24, and if I add 6 and 4, that's 10. It is, but you have to be careful with your signs. Because you can also do 12 minus 2 and get 10. So you have to kind of, pair on which one you have. So it's all about the signs here. With the b term being negative, the bigger number has to be negative. If you divide a negative and a negative, that makes the other number a positive. So if one's positive and one's negative, the only way to get to 10 would have to be the 12 and the 2. Okay, and then setting both of those equal to 0, t would equal negative 2, and for this one we get t would equal 12. Okay, so it's really just a factoring problem. But again, if I talk about the excluded values, all you're going to factor then is the denominator, and then just factor that and go from there. And if the numbers happen to repeat, if we factored this one off and if it was both the answers were 4, you only have to put 4 one time. And it just depends on the problems, on how they set this thing up and what they go through these. But most of the time it's 2 answers if it's t squared or x squared, but sometimes it may be the same answer that repeats. If that's the case, you only have to write it one time. Alright, so let's go to the next page here. Okay, now, and here's what if it's linear equations, basically it comes down to that there's really more of 3 things it's not going to be. Didn't leave enough room here, so let's do that. We'll come back there. Didn't leave enough room here. So the first thing is it's variables with a power greater than 1. If you have x squared, and all these should be in x's and y's because they're talking about graphing these with y equals mx plus b type things. So if you get an x or a y with a power that's greater than 1, then you start having curves. Then if it's x squared, you're going to have a parabola like this. If it's y squared, you're going to turn it this way. So if you have x squared or y squared, then that's not going to make it linear. It's going to have some curve to it. Okay, you cannot have variables in the denominator. Because if you have variables in the denominator, kind of like with the objectives we had right before this one, if you have a variable in the denominator, then you start saying, all right, you can have every number you want to plug in except for this one number or these 2 numbers. And it may be that if you're doing that, you're going to have a line that's here, but then you're going to have a hole in the graph. So you might have a hole here, and you might have a hole here. And it actually will be a hole that's just jumped out on that one, so it's not linear because you've got these different missing pieces and parts of it there. So that's kind of the why you don't have denominators. And then kind of along the same lines here is that you cannot have x times y. Because if you separate them out, you're going to divide by one of the variables, which then puts that variable in the bottom, which then you're back to having the gaps and the holes in the graph of this thing. Okay. And there's only this one objective that's here, and all they're going to do is they're just going to keep giving, they're going to give you a list of 4, I think each problem you're going to have 4 different equations, and you're just going to click function or equation or not equation, or linear or not linear. It's either yes or no type answer. And we'll just list off like 5 or 6 of them here, just so you can kind of see what's going on. Okay, 4x minus 3y equals 10. And we'll just put yes or no. Okay. We don't have x times y. We don't have variables in the denominator. All the powers are 1. So they ask you, is this thing a linear function? And again, it's either yes or no. That one's okay. X over 2 plus y over 5 equals 10. Now, you've got denominators, but they're whole numbers, constants, so that's okay. So that one's still a yes. Now, if you were to switch it up and do something like this, that one would be a no because you've got the x down here. So for that one would not be a function. Okay, 3x minus 6y plus 10, then 4x minus 15. Even if you have x's and y's all over the place, numbers all over the place, you're still looking for the same thing. There's not x times y, there's nothing in the denominator, they're all in the first power. So that one's good to go. 3x squared minus 5x plus 2y equals 10. Again, you got x squared. That makes it no. And sometimes they'll throw in a really short one. Y equals 2. Still the same thing. There's no variables in the denominator. You don't have x times y. Everything's to the first power, and you're like, what about the x? Doesn't matter. As long as there's just because that one would basically just be a horizontal line. It's going straight, so even that one's still okay. As long as it doesn't have those three things in it, then we're good to go. Okay, and then the last one. And maybe something like this, where you got 6xy plus 2y equals 17. But again, as soon as you got x times y, makes that one enough.